I am a design researcher in Berlin, and in my work I investigate on the correlation between design and so-called disabilities. And you know, each of us has certain connotations with the word disability, and for some reason most of them are rather negative. So I asked myself, how could we change things by interpreting disability not so much as a deficit, but more as an expertise? So I discovered many disability-related aspects that can actually be transferred to the design of human-computer interaction. And there's quite a lot we can learn from certain disabilities, from certain alternative ways of perception, of communication, and we can bring them to design. So based on that, we have developed a couple of prototypes for new interaction systems. And it's very interesting. What they all have, or what they all seem to have in common, is that they do not only serve specific needs for certain groups of people, for example, help deaf people to communicate with others, but they can actually be helpful to all of us. During my research, I've been conducting several participatory design workshops with different people, mainly deaf people and blind people. And in one of our first workshops, we were discussing the idea of mobile telecommunication in the context of deafness. And one of the most striking issues that came up referred back to the question of how is a deaf person supposed to actually use a mobile phone when he or she actually needs both hands for sign language. So one of the participants addressed this problem and expressed this problem in a very hands-on, in a very graspable way. She came up with this little prototype here, symbolizing, hey, I need something, I need a phone that is able to be hung up wherever I like, whenever I need it, which is kind of interesting because don't we all know many situations where we could need certain hands-off communication, for example, when we work in the kitchen or when we drive a car. So that was for me the starting point to really think deeper in terms of how can we transfer certain concepts from a disability context to other fields. And in another project with another deaf group, we have recently developed a mobile application which enables the user to achieve immediate attention of nearby friends by simply pointing at the person, pushing a button on your phone, then the other person's phone vibrates and shows your name, displays your position, so the person sees, okay, Tom is standing 50 meters behind me, right behind me. So, you know, there's no need to call the person, no need to send an SMS, which can obviously be very helpful to deaf people or hard of hearing users. But it can actually be also helpful to non-deaf persons. Let's think about very loud or crowded environments. In one of our most recent projects, we are focusing on the aspect of deafblindness. And as you can imagine, people who cannot hear and cannot see at the same time do not have so many people to talk to. So one common way of communication for the deafblind is some kind of tactile hand-touch alphabet called LORM, in which the characters are assigned to certain areas of the hand. And of course, the conversation partners have to be familiar with that language, and also the physical contact is necessarily to speak with each other. So we still have a lot of social isolation with the deafblind. Now, Ulrike and I have developed the mobile LORM glove, which is a communication device that translates the German LORM alphabet into digital text and vice versa. And therefore, we use small fabric pressure sensors that enable the deafblind user to compose text messages that are transmitted to the receiver's phone or computer. And on the back, we have small vibrating motors that allow the wearer to perceive incoming messages through vibrotactile feedback. So now it is possible to send messages even over distance. You can send them from one glove to another. You can send them to mobile phones or to computers. And of course, vice versa. You can receive emails, SMS, stuff like that. So this is something that really helps to support the social inclusion of the deafblind. It also enables you to speak to more than one person at the same time. That was also not possible before. So it helps deafblind people to gain access to a broader range of information and to literally get in touch with a broader variety of people. So again, we have something that can be helpful to a certain group of people, but on the other hand, this group's specific way of communication could also be an inspiration to other fields. That's why we are currently investigating on different areas of operation where such kind of haptic interaction could be embedded into wearable technologies. Let's think of people who work, machine workers who work in a factory. Usually they work in a very loud environment. Or let's think of situations where people either cannot or must not speak very loud. Let's say a stagehand in a theater. So the point behind it is, if we learn to acknowledge the expertise of disabled people, we might not only become able to, come up with cool stuff that helps us to make the world a little bit more accessible, but, and that's maybe even more important, it might also help us to slightly modify our common understandings of so-called normality. Thank you.